have I told you lately that stars in our universe primarily spend most of their time in the main sequence? This is when they are getting their energy primarily from nuclear fusion. You have two primary ways that this can happen. For less massive stars, think stars that are less mass than our sun, all the way up to about 1.3 solar masses, you're going to see the proton-proton chain. For stars that are more massive than that, you're going to see the CNO, or carbon, nitrogen, oxygen cycle. First of all, the CNO cycle, like the proton-proton chain, is taking 4 hydrogen nuclei and converting it into 1 helium nucleus. But since our star is a main sequence star going through the proton-proton chain, let's start there. For the proton-proton chain, the first step in all of this is that you need a place that there is enough pressure to get 2 protons close enough together that the strong nuclear force can bind them together. And that takes place in the cores of stars. The resulting combination of these 2 protons is, much like my relationships when I dated men, unstable. And so one of these protons is going to decay and become a neutron. This then forms the stable nucleus of deuterium. That deuterium nuclei that was produced in step 1 will then, in step 2, collide with a proton to form the nucleus of helium-3. And through this, you're going to see the release of a gamma ray. Lastly, we need 2 helium-3 nuclei to collide, and that collision results in the formation of a helium-4 nucleus. You also get 2 protons that are released, and they go on to repeat step 1 or 2. And that is a very generalized overview of the proton-proton chain. Very exciting, isn't it? For stars more massive than our sun, they are going to undergo a process that's actually much more efficient. So how does the CNO cycle go through this process? So the first step in all of this is a carbon-12 nucleus captures a proton. Through this, a gamma ray is going to be emitted, and this results in nitrogen-13. The nitrogen-13, which is unstable, emits a beta particle, and this results in the creation of carbon-13. Carbon-13 captures a proton and via the emission of a gamma ray becomes nitrogen-14. Nitrogen-14 captures yet another proton, and by emitting a gamma ray, we get oxygen-15. Via a process called beta decay, our oxygen-15 becomes nitrogen-15. Nitrogen-15, you guessed it, captures a proton, and this produces a helium nucleus and carbon-12, which brings us right back to the beginning. It's like a circle of life, if life was the process of nuclear fusion. So there you have it. That's how stars undergo nuclear fusion. I know that this is something that you have really, really wondered about. You've laid awake at night, curious about the difference between these two things. Now, if you excuse me, I need to go get this hair product out of my hair because I had a lot of flyaways and it feels